Good morning, this is your Stats Sensei, Mr. Sensei, and this is Death Packet for Unit 3A, Classical Probability. These will be problems 51 through 60. Suppose X and Y are random variables with a mean of 32 and a standard deviation of 5, and Y has a mean of 44 with a standard deviation of 12. Given that X and Y are independent, remember they have to be independent to add standard deviations. They don't have to be independent to add means, but they do for standard deviations. Says, what are the mean and standard deviation of X plus Y? Well, the mean is going to be simply 32 plus 44 or 76. So that gets rid of this. The standard deviation, on the other hand, is going to be 5 squared plus 12 squared. And then we'll have to take the square root of that. All right. And when we do that, we're going to get 25 plus 144, and that'll take the square root of that, and that'll give us 13, because we'll end up with the standard deviation of the square root of 169, which happens to equal 13. All right, next one. Biologists are analyzing soil to check for the number of worms and grubs in a wildlife preserve. Let the random variable W represent the number of worms found in 1 square feet of soil, and let the random variable G represent the number of grubs found in 1 square foot of soil. The following table shows the probability distributions developed by the wildlife, developed by the biologists for W and G. All right, assume that the distributions of worms and grubs are independent. Again, important if we're going to add standard deviations. What are the mean and standard deviation for the total number of worms and grubs in 1 square foot of soil? So what I recommend doing is this in a couple parts. We're going to input the W's into L1 and then the frequencies into L2. Now I've already done that. I went to stat edit and I entered those values. So basically L1 and L2 all the way across. And then I'm going to press stat, arrow over to calc, 1var stats, blue button 1, and then frequency blue button 2. And I end up getting a mean of 2.98. So the mean of W is 2.98. And the standard deviation of W was 1.2081. I'll just show you that real quickly on my calculator. Mean of 2.98, standard deviation 1.2081. Then I'm going to do the same thing for G. I don't have G in my calculator yet, but I will soon. So I already have the G values, but I don't have the frequency, so I need to change those. 0.21, 0.27, 0.38, 0.05, 0.03, 0.01. All right, I have those in there. And then once again, I'm going to press stat, arrow 1 space over to calc, press 1var stats, L1, L2, which I already set. And I have a mean of 2.3. So the mean for the grubs is 2.3. And the standard deviation of the grubs is 1.1532. Standard deviation of grubs is 1.1532. All right, we'll do the mean first. So on the mean, it's fairly easy. We're just going to add them directly. 2.98 plus 2.3, and we get 5.28. All right, so we get 5.28, which gets rid of these. Now we need to do the standard deviation, but in order to do the standard deviations, I'm going to take the 1.2081 raised to the second power plus 1.1532, raise that to the second power, and then take the square root of that, and the standard deviation of W plus G is what that gives me. Scoot this down just a little bit. All right, so here we go. 1.2081 squared plus 1.1532 squared, and I'll press enter. And then I'm going to take the square root of that, which I do by raising to the half power. I use this button, raise to the 0.5, and I end up getting 1.67. So We already had the 5.28. Our 1.67 is here, so our answer choice is C. Moving on, question 53. The Financial Aid Office at a state university conducted a study to determine the total student cost per semester. All students are charged $4,500 for tuition. The mean cost for books is $350 with a standard deviation of 65. The mean outlay for room and board is $2,800 with a standard deviation of 380. The mean personal expenditure is $675 with a standard deviation of 125. Assuming independence, which is important if we're going to add standard deviation, what is standard deviation of total cost? So in this case, we have a standard deviation of 65. We also have a standard deviation, that's that one. We also have a standard deviation of 380. And we have a standard deviation of 125. So in order to add them, I'm going to have to square them first. So it's going to be 65 squared plus 380 squared plus 125 squared. And then ultimately we'll come back and take the square root of that. So 65 squared plus 380 squared plus 125 squared. Then I'm going to raise that to the half power. And again, I use this button right here, raise it to the 0.5, and I get 405. So my closest answer is D. Number 54, as a promotion for the first 50 customers who entered a certain store at a mall, we're asked to choose from one of two discounts. Okay, so they're choosing one of two. The first discount was a choice of 20% off all purchases made that day. The second choice was 10% off all for the week. All right, so you either choose 0.20 for the day or 0.10 for the week. And it's key that you only get to choose one of those. Of those who received the discounts, 28 chose the first and 22 chose the second. One customer will be selected at random from those who received a discount. Let F represent the event that they chose the first discount, and let S represent those who chose the second discount. Are F and S mutually exclusive? In other words, is there an overlap? Are they going to look like that? That's mutually exclusive, or do we have some sort of overlap? Well, in this case, we could either choose this or this. We could not choose both. And because we could either choose this, the first or the second, and not both, that means there's no overlap. Since there's no overlap, it's going to look like this. There's no intersection. Our intersection is actually 0. So there's no overlap. And so, yes, they are mutually exclusive. So the table shows data that were collected from people who attended a certain high school basketball game and indicates that the team each person rooted for and whether each of those purchased food during the game. So I either rooted for the home team or I rooted for the away team. Notice I didn't root for both. A person who attended the game will be selected at random. Which of the following correctly interprets mutually exclusive events represented by the table? Well, I could either choose the home team or the away game or the away team. So rooting for the home team and rooting for the away team, that's definitely a possibility. I like that. Rooting for the home team and purchasing food. Well, I can do both of those. And if I can do both of them, purchase food and rooting for the home team, that's 120 people. So there's an overlap. So there's not this. Rooting for the away team and purchasing food. Well, I can do both because there it is at 40. So can't that if there's an overlap, it's not mutually exclusive. Rooting for the home team and not purchasing food. Oh, I can do that. Not mutually exclusive. Rooting for the home team and not purchasing food during the game. Rooting for the home team and not purchasing food. Oh, those are the same. Anyway, but regardless, those two can't be. The only one that could be here. Oh, and then we have rooting for the home team and not put, and we already said that's gone. All right. So I can either root for the home team or the away team. There's no overlap. So that will work. I could have also said purchase food or didn't purchase food, and that would have worked. But the combinations, if there's a joint probability, there's an overlap, then not mutually exclusive. Number 56, a high school science teacher has 78 students. Of those students, 35 are in band, 32 are on a sports team, and there are 16 who are not in band or on a sports team. Oh, well, that's interesting. So let's add these up. 35 plus 32 plus 16. That equals 83. But he only has 78 students. That means 5, 83 minus 78 gives me 5. 5 must be in both. All right. So this is what this would look like on a Venn diagram if I were asked. I'm going to put band and sports. Well, there's going to be 5 here that are doing both. There's actually 16 out here and 35 in band. So this would be 30 because 30 plus 5. And here we have 32 minus 5 is 27. This plus this plus this plus this should equal the 78. So let's make sure that that's right. 30 plus 5 plus 27 plus 16. Sure enough, that equals 78. So this is the way the Venn diagram would look. So let event B represent the selecting student from band and S from selecting student from a sports team. Are B and S mutually exclusive? Well, no, I see an overlap. Well, they gave it to me as proportion. So basically, they're saying we want to divide all of those by 78. And so 5 students out of 78 are in both. So this is a no because there is an overlap. All right. Anytime it's an overlap, not mutually exclusive. They can be independent, but not mutually exclusive. The students at a certain high school have an elective period where each student chooses an elective. Oh, an elective means I'm choosing just one from among 4 options. So I can either choose art or music or physical education or engineering. The following table shows the number of students selected, each elected for the 1,500 students at the high school. One student from the school will be selected at random. What's the probability the selected student chooses art and the music? Wait a second. They can only choose one. They can't choose both. So they're mutually exclusive. The probability of that happening is 0. A survey of people on pizza preferences indicated that 55% preferred pepperoni only, 30% preferred mushroom only, and 15% preferred something else. Let's add that up. So 0.55 plus 0.30 plus 0.10 or 0.15, excuse me, equals 100%. So we have a valid probability distribution. And the fact that I can add those probabilities up as there are mean there is absolutely no overlap. So suppose one person who was surveyed will be selected at random. Let P represent probability they preferred pepperoni, M the probability they represent mushroom, are P and M mutually exclusive events? Well, we just showed here that it's summed up to 100%. So consequently, there's no overlap. So are they mutually? Yes, they are. So let's get rid of those no's. Because the joint probability of P and M is greater than 0? No, not greater than 0. It equals 0. Yes, because the probability is greater than 1? No. Yes, because the joint probability of P and M is equal to 0. All right. The joint probability is the overlap. There is no overlap. And we checked that out because when we added this up, it added up to exactly 100%. All right, number 59. At a local elementary school, 35% of all students have brown eyes. 45% have brown hair. and 60% have brown hair or blue eyes. Oh, so that means that's the union. So I'm going to use the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Well, this is 0.60 because they said that that was the OR. That's the union. This is 0.45 and this is 0.35. Now I could have swapped the order. It wouldn't have mattered. Minus the intersection. So this is 0.60 equals 0.80 minus the intersection. So I subtract 0.80 from both sides. And I get negative 0.20 equals negative n. Flip my signs, and I find that I have an overlap of 20%. So are they mutually exclusive? No, there's an overlap. So first off, the yes is gone because no, there's an overlap. And the overlap happens to be 20%. We just found it. Given events A and B, independent events A and B, such that A is 0.3 and B is 0.05, which of the following is the correct statement? So the probability of A given B, if they're in, well, first off, this is always true. Probability of A given B, this is always true right here, is the probability of A and B over the probability of B. So that's always true, but they told me they were independent. Well, that means if they're independent, it'll have to equal the probability of A. Well, A is 0.3 and this said 0, so that's wrong. All right. So this one, the probability of B given A. Well, the probability of B given A, because we know they're independent, means it has to equal the probability of B. Well, B is 0.5, so that's wrong. We already said that had to equal 0.3 because that's what we said here, so that's wrong. So now we need to check out the A union B. Well, they're independent, so probability of A times the probability of B equals the probability of A times the probability of B. Oh, excuse me. Probability of A intersect B equals the probability of A times the probability of B. So this equals 0.3 times 0.5. That equals 0.15. So the probability of A union B equals the probability of A plus the probability of B minus the intersection. Well, we just said the intersection was 0.15. We just found that. And we know this is 0.3 and this is 0.5. So this equals 0.8 minus 0.15. So this equals 0.65. So this is our answer. All right. Okay. Appreciate you watching. Hope to see you on the next one. Thank you.